Hello students, welcome to AVN Knowledge. Kindly subscribe this channel for physics, electrical capacitance, and if you have any comment, kindly comment. So at first we start the electrical capacitance. What is the capacitance? Means capacity. Capacity means potential energy. We have stored as a potential energy just like the electrical energy. So the first term we study about the conductor, semiconductor and insulator. Insulator, or you can say non-conductor. So we all of know about the conductor. What is conductor? In which the current flow, that is called the conductor. For example, ferrous, iron, aluminium, silver, etc. metals which are the conduct, they have the free electrons outermost orbital. Next, that is the semiconductor. Semiconductor, at the low temperature, this behave as an insulator, and when we increase the temperature, this behave as a conductor. So this current flow at high temperature and current does not flow at low temperature in semiconductor. Then we insulator. Insulator means current does not flow. They have no free electrons in the outermost orbital. So the second point is we explain by the energy gap. Here some conduction band and valency band. This is the conduction band, this is the valency band, this is the conduction band, this is the valency band, and this is the conduction band, and this is the valency band. The gap between conduction band and valency band is called by the energy gap. So you can say here is the less energy gap and here some increased energy gap, and in insulator the energy gap is more. So here the energy gap is approximate equal. So the valency band electron easily move to the conduction band and the electron free to move in conductors. Here the energy gap, valency band electron at low temperature, this is not possible. But when you increase the temperature, the electron move to the conduction band and free electron for the semiconductor. So in semiconductor, when at low temperature, this behave as a insulator, and when you increase the temperature, so valency band electron move to the conduction band and easily flow the current. And in insulator, the electron of valency band doesn't move to in conduction band because here the energy gap required more than 3 electron volt, and here the energy gap is approximate 1 electron volt. And the maximum energy gap in diamond, that is the 7 electron volt. So we can say the conductor, semiconductor and insulator, they have the properties flow of current easily at low temperature. This behave as a conductor, this behave as an insulator, and when you increase the temperature, this behave as a conductor. So at room temperature, this is behave as an insulator, and when you increase the temperature, this behave as a conductor. So the basic concept of conductor, semiconductor and insulator. Then the next topic is dielectric constant. The dielectric material dielectric substance and polarization. Dielectric substance means current doesn't flow in this substance. In dielectric substance, current does not flow, but when you apply the electric field, this shows the electric effect. So we can say this is the insulator. Yes, dielectric is insulator, but all insulator is dielectric. That is not conceptual. Dielectric means current does not flow, means that is the insulator. But when you apply the electric field shows the electric effect in the dielectric substance. In insulator, all insulator are not dielectric substance. For example, dielectric substance like the ebonite, wax, oil, etc. paper. So these are the dielectric substance, means current does not flow in this substance, but when you apply the electric field, electric effect shows. That is the dielectric substance. Insulator, dielectric substance, a part of the insulator. All insulators are not dielectric substance. So we can learn about the dielectric substance, that is the current does not flow, but in electric effect, when you apply the electric field, then the electric effect shows the dielectric substance. So we study about the dielectric substance. There are two types of dielectric substance. The first is polar dielectric and second is non-polar. At first the definition. In polar dielectric, the center of mass positive charge and center of mass negative charge doesn't coincide. Doesn't coincide means the center of positive charge and center of negative charge are separated. And here the center of positive charge and center of negative charge are coincide to each other. For example, here H2O, HCl, NaCl, NH3, and here non-polar examples are H2, O2, CO2. We take the example of H2. So here H plus, and O minus. So we can calculate what is the center mass of negative charge. This is the negative charge. And what is the center mass of positive charge? This is the positive charge. And we can calculate the center mass of positive charge and center mass of negative charge does not coincide. And we can other example of HCl, means this is H, this is Cl, this is H, this is Cl, H plus, Cl minus. So here, what is the center mass of positive charge? This is the center of mass positive charge. What is the center of mass negative charge? This is the negative charge. They are the separated because they have some distance. What is the electric dipole moment? Q into 2a. So here we separate distance in the polar dielectric substance. And here non-polar, the example of S2 means H plus H plus, or we can take example of CO2 O minus, O minus, and when they coincide, the center of mass H plus and H plus, they are coincide to each other. Here H plus, the center of mass H plus will be center. Here the center of mass negative charges, center of mass negative charges here, and positive center of mass is here. So they are coincide to each other. So when you calculate P equal to Q into 2A, the 2A is 0 because they coincide to each other, because here they are the separated. So center of mass positive charge and center of mass negative charge are separated in the polar dielectric, and center of mass positive charge and center of mass negative charge are coincide to each other, means they are not separated. So the electric dipole moment when calculate, the P net will be 0. Here P net will not be 0. Electric dipole moment in polar dielectric, P net means net electric dipole moment will be 0. And here the net electric dipole moment will be 0. Here net electric dipole moment will not be 0 because they have the separated. The positive and negative charge are separated, and here they are coincide because the positive center mass of positive charge and center mass of negative charge also coincide to this point. So separate distance is 0. When separate distance is 0, the net electric dipole moment will be 0. So we can explain the polar dielectric and non-polar dielectric. The definition is, here the definition, the center mass of positive charge and center mass of negative charge does not coincide, means they are separated and say they have some distance. When they say have some distance, the net electric moment they have, and they have not because they have not the center mass of positive charge and center mass of negative charge, they have coincide, means not separation means distance is 0. So electric dipole moment, net electric dipole moment in non-polar will be 0. Next we see what is the electric effect of polar dielectric effect and what is the electric effect on non-polar dielectric. Next point is effect of electric field on polar dielectric and effect on electric field on non-polar electric effect. So when this is a substance of polar dielectric and when the electric field is applied, here electric field is 0, means electric field does not apply. Case first is electric field does not apply. Case second is electric field is applied, means electric field is does not 0. And what is the polar dielectric? This is the polar dielectric, minus plus. They have the randomly situations in absence of electric field. The moment plus minus randomly motion when electric field is 0. When we applied at this electric field, they feel a electric force on the polar dielectric material and they separated in a linear, just like minus plus 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 minus plus. Here when electric field is 0, they have the random motion. So net electric field is, if you calculate P net, that will be 0. When we apply the electric field at this substance, they feel a electric force on this polar dielectric, and they separated in a linear. So this positive charge will be cancelled out with this negative, this positive cancel out this negative, and here the last positive and here the last negative, they negative charge and positive charge develop a induced charges and induced electric field, that is called EP. So here induced electric dipole moment is generated. So this electric dipole moment generated, a electric dipole moment is generated. So here when we apply the electric field on polar dielectric effect, P net will not be 0. This is the generated. So when electric field is not applied, they have a random motion, and when electric field is applied, they separated in a linear due to the electric field force, and the electric field, induced electric field by the polar dielectric substance, and this direction will be opposite to this applied electric field. The electric field is direction is positive to negative, so EP direction is here positive to negative. So this induced electric field will oppose the applied electric field in the polar dielectric field. Same thing when we see in the non-polar, when electric field is 0 and when electric field is applied. When electric field is 0, the coincide, so shape is circular, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative. Here the electric field is not applied. When the electric field is applied, they polarized, plus minus, plus minus, plus minus, plus minus, like this, and this is also, as well as this negative cancel out the positive charge, positive cancel out, and here the last positive charge and last negative charge, this charge induced the electric field. So this is when E is not equal to 0, means electric field is applied. This is the case second, and case first is electric field is applied. So when we apply the electric field, a induced electric field is generated which oppose the applied the electric field. So here P net is generated, that will be not 0. So we can see when the electric field is applied in dielectric substance, they affect the electric field. The definition of dielectric substance means when we apply the electric field, their substance affect the electric field. Means here the electric dipole moment is generated, here the electric dipole moment is generated. So next we have learned about the effect of electric field on polar dielectric and effect of electric field in non-polar dielectric substance. The next topic including this, vector polarization. What is the vector polarization? Vector polarization. The vector polarization is the unit volume electric dipole moment. Means electric dipole moment upon volume. Per unit volume electric dipole moment is called by the vector polarization. Vector polarization per unit volume electric dipole moment is called by the, this is the small p, we can say electric dipole moment, and volume per unit volume electric dipole moment is the vector polarization, and this vector polarization is proportional to the electric field. And here electric, when we use a constant, that is the chi e. What is the chi e? Chi e is a electric constant, that is called by the electric susceptibility. Electric susceptibility chi is. Chi is a electric constant, that is called the electrical substitution. This constant have a new physical quantity. So when a new physical quantity, what we have about this unit, dimension and quantity. Quantity is constant, so scalar. Dimension, this is the dimensionless and unitless. So dimension will be m naught, l naught, t naught. So chi here is a constant, that is the dimensionless quantity, and p is the vector polarization. So this is the basic difference between non-polar dielectric and polar dielectric substances.